Ladies and gentlemen, please welcome Tim Von Gall, COO and partner, Urban Exposition's Expo producer.
Love that music. Good morning, everyone, and thank you for being here. Our company, Urban Expositions, owns, manages, and produces 40 events around the country annually. But I can't think of one industry that we serve that is more exciting, vibrant, energetic than this one. And we thank you for allowing us to be a part of it. Speaking of thanks, I'd also like to express our deep appreciation to two undisputed industry leaders, Flying Magazine, our title sponsor, and Shaden, who without them, none of this would be possible, and we thank them tremendously. We'd also like to thank all of our sponsors and remind you that we've got a wonderful exhibit hall out there that we'd love for you to visit, and make sure you spend lots of money out there. We've got great seminars, great speakers, and we're just so thankful to be here. So thank you very much. With that, I'd like to introduce the founder and president of our aviation division, Lift Management, and that would be Marco Parado. Please welcome Marco.
Hello everyone, welcome. What a great morning. That weather's finally past us. Did everyone see that parade of planes yesterday? Fantastic. Well, like Tim said, I'd like to thank all of our sponsors, especially Shaden. You know, over a year ago, when I had this idea to launch this, I picked up the phone and called Flying Magazine. Without hesitation, they were on board with us. And like Tim said, this wouldn't be possible without them. And please see the static displays as well. When you buy an airplane, we have every manufacturer out there be happy to sell you an airplane. So without further ado, I want to thank and welcome to the stage my friend, Editor-in-Chief, Flying Magazine, Stephen Pope.
Thanks a lot, Marco. Thanks. Hi, everyone. Good morning. Welcome to Flying Aviation Expo. I'm glad that you could all make it here. Thank you very much to Marco and Tim and everyone at Lift and Urban for all of their hard work, everything they do behind the scenes. Really, this show wouldn't be possible without them. I mean, that's no joke. So we have an interesting and exciting keynote speech this morning that I will be introducing you to a couple of people who will be talking about the future of electric airplanes in general aviation. This is an area of aviation that we very simply can't ignore. It's coming on strong. We have companies like Airbus and Pipistrel and Diamond Aircraft are all coming on with electric airplanes that they are either flying now or preparing to fly very soon. And so it's really something that we have to look at. As an aviation journalist, I'm a little bit skeptical of, when we're talking about batteries and electric motors and solar cells on wings. But, people are putting a lot of time and effort, some very smart people. So I think that there is a future for electric airplanes, and we'll see where it goes. Okay, but before I do that, I want to ask a question. And the question is, when did the world shrink? When did the chasm between continents become so small that the world just seems like a very tiny place? And this is an aviation savvy audience. And so we might say December 17th, 1903. The Sand Dunes Kitty Hawk with the Wright brothers, the first flight, and that's absolutely true. Commercial air travel today, you can get on an airplane and travel from any point in the world to any other point in a matter of hours. And it really is just incredible. But actually, the world became a smaller place much earlier than that. The date was August 16th, 1858. And that's the date that the transoceanic cable linking Great Britain with North America was finally finished, and the first message was sent and received. And when that happened, suddenly communication between the continents that would take a month with ships, or in bad weather even longer, could be done in the span of one day. And it truly made the world a smaller place. And now today, incredibly, I have my iPhone, and I can access data anywhere in the world. I can get anything I want. I can play a live game of chess with an opponent in Bangladesh. I can take a selfie and post it on Facebook. Here, everyone smile. No, I'm kidding. I'm a pilot. We only take selfies in the cockpit. Everyone knows that. And so really, if you were to ask the average person on the street, how is this with an iPhone sending data halfway across the world, how is that possible? And they would probably say satellites. But that's wrong. Almost no internet traffic travels through satellites. They travel through undersea fiber optic cables that wrap around the globe to deliver information at the speed of light to billions of people. I mean, it's absolutely incredible what we can do here. And really, the driver behind this is electricity. It's electricity that made the world smaller in 1858, and it's electricity that makes the world a smaller place today. And now we're coming to a point where electricity is going to play a role in general aviation and aviation in general's future. This is a cover article that I did. This is the Airbus eFan 4.0. So this is a 4-seat hybrid electric airplane that Airbus is going to bring to the market in North America, and it's not happening 20 years from now, it's not happening 10 years from now, it's happening in just a few years. They're going to introduce the first a 2-seat trainer, which you'll hear a lot more about in a second, and then they're going to introduce this airplane in 2019. So think about that, we're almost in 2016, and this airplane, Airbus says, will be on the market in 2019. So the first person I want to introduce you to is actually through a video, and he is Jean Botti. He's the Chief Technology Officer for Airbus Group, and he's here to tell us a little bit more about what Airbus is doing with electric airplanes. Can you play the video?
Hi there, to the attendees and organizer of Flying Aviation Expo. Thank you, Stephen, and the Expo organizer, and all of you attending, for a warm welcome you have given to both the Airbus Group and me. I very much regret that I'm unable to be there in person this week, but I'm nevertheless very honored to be part of the Flying Aviation Expo. As Stephen has told me, this year's event is being attended by several thousand active and engaged general aviation pilots and aircraft owners, as well as by representatives from the US flight schools and over 300 brands and industry leaders. There are 75 aircrafts on display, plus education and hands-on demonstration, over 50 sessions. Flying Aviation Expo is a gathering of the kind of pilots, aviation enthusiasts, and experts of innovators and explorers who became the founders of what is Airbus Group today. At the dawn of aviation a century ago, it was a race to be the first to fly an airplane across the English Channel. For aviation pioneers like Louis Blériot, who made the epic trip in 1909. At Airbus Group, Blériot innovation spirit lives on. Last July, our eFan technology demonstrator proved itself a trailblazer into aviation's next technological frontier. As the world's first all-electric two-engine aircraft to take off by its own power to cross the channel, the eFan completed its historic flight of 46 miles between England and France in 36 minutes. The Channel crossing isn't just a clear proof of the viability of electric flight. It has also set the stage for the next project phase, the commercial production of all EFAN, all-electric 2 seats called EFAN 2. Entry into service is slated for late 2017. Why will the EFAN 2.0 be flying first? With its size and endurance of an hour flight time plus 30 minutes of reserve, we think it's ideally suited to the need of training flying schools. Our goal is to work together with you, pilots, and aircraft owners, instructors at flying schools to enter the next phase of aviation. The aerospace industry is still a young one, and Airbus remains committed to being at the forefront of innovation. There is strong incentive for Airbus Group and other manufacturers not only to develop innovative, eco-friendly, propulsion and lightweight material solutions. We also need to bring them to market quickly as more stringent emissions regulations come into effect. With its EFAN project, Airbus Group is expanding its role as an innovator leader in bringing technological advances to market. It will also make aviation more environmentally sustainable and energy efficient in the future. The EFAN program shows that large companies like Airbus Group can still work as a startup, in a startup manner, and develop small-scale pioneering projects. EFAN isn't our only foray into innovative flight. You may remember the first flight of the Pearland 2 glider in late September. It's the first part of the Airbus Pearland mission 2. The goal for this mission is to soar the aircraft to the edge of the space at 90,000 feet in Argentina, and it will be in July 2016. This flight is expected to exceed even the altitude achieved by the U-2 and the SR-71. We hope that our work into innovations like the EFAN and Pearland 2 will capture the imagination of the next generation of aviators and engineers and encourage them to pursue their dreams of flying. We're proud, as Airbus Group, to be part of the Flying Aviation Expo community of pilots, industry experts, flight instructors, and aviation enthusiasts. In summary, here's a look at the EFAN technology and the story so far. I wish all of you a very productive and a great time at the Expo, and I hope to be there next year.
Okay, gentlemen. Thank you.
En fait, c'est une journée assez symbolique, puisque on va retraverser la Manche un peu plus de 100 ans après Berriot.
If I'm right turn.
You are clear to proceed at the right turn and clear to 3,500 feet. The helicopter, EFAM, good morning. EFAM, the helicopter, the search and rescue helicopter, loud and clear. That's fine, and can I talk to Dominic Perimetry? Yes, sir. EFAM, Perimetry. Okay,
How about that? Let's give Airbus a round of applause. Thank them for that. So there you have it. These are the types of things that people are working at. There are a number of companies and entrepreneurs that are putting a lot of time and effort and money into bringing these airplanes to us. And when it will happen, it looks like it's going to be moving forward pretty quickly because there's a lot of competition and everybody wants to be first. Pipistrel has created the Alpha Electro. This is an all-electric airplane as well, based on their two-seat Alpha that's powered by a Rotax engine. And this is the first serial production electric airplane in the world. There are other concepts coming. This here is Diamond Aircraft's e-tiltrotor project, which they shared with us on a trip to Austria last month. And I mean, this here, talk about being skeptical of something. I mean, I look at this and I say, no way. This would be powered by 4 electric motors produced by Siemens, which is a partner of Airbus and has been working with Pipistrel. It would also have Austro diesel engines that would power a generator to keep the batteries topped up in flight. It would be full fly-by-wire, and it would take off like a helicopter and fly like an airplane. Diamond has a major industrial partner for this project that they haven't named, but there's only a couple companies in the world that it could possibly be. And so we'll see. I mean, this is another exciting possibility. So the next person I'd like to introduce you to is a pioneer in this field, an entrepreneur. His name is George Bai. He's the founder of Aero Electric Aircraft Corporation. And I won't go too much into George, but George has been at the forefront of this from the very beginning. He's probably one of the most knowledgeable people in the world about electric aircraft, and he has some very interesting things to say about the future of electric aircraft, and I think some surprising things. So George, can you come up to the stage? Thanks very much.
Absolutely. Well, good morning. 7 years ago, we were developing a small electric drone and progressed over a series of research and development processes. It took probably a couple of years before that small 14-foot drone was really ready to begin performance and had the capability that it does today. It taught us many things about the possibility of electric flight, how it might transform in terms of endurance and cost and noise and pollution, all those kinds of things. It was a learning tool. That airplane today is in production, 7 hours of flight time, a very, very cool tactical drone. About 5 years ago, some of you may remember that we announced a conversion of an airplane to an electric propulsion. That was a partnership with Jack Pelton at the time at Cessna, our own Charlie Johnson, who was formerly the president and COO of Cessna. Some of you may remember that. It was a great announcement. We did it at Oshkosh, and what fun. We talked about the possibility of scaling up to a manned aircraft, electric propulsion, and all the benefits that might mean. I remember in an audience something like this, and we made the presentation, and there were two key questions at the end of that presentation. One question was, George, how come nobody else? How come nobody else is doing this? This is really cutting edge. This is way out there. Batteries are heavy. And of course, we appreciate Airbus. Now we don't have to say we're the only people out there pioneering this. We appreciate Pipistrel and Diamond and others. For us, general aviation matters, doesn't it? So I'm glad that this is a community effort from the leadership. Of course, the second question they asked me was, George, how long is your extension cord? Unbelievable. Well, we flew that Cessna about 20, 25 times. And I think one of the things we all understand in research and development, this kind of progression in technology is not a trivial exercise. We started with an electric motor that's the size of a watermelon. The batteries were heavy, that is for sure. In terms of energy density, about 160 watt-hours per kilogram. Today, just a few years later, 275 watt-hours per kilogram. You know, what does that mean? It means the amount of energy stored in batteries has doubled in just a few years. You know, the possibility of electric flight seemed just too far of a reach just a few years ago. That technology is coming together now like it never has before. That electric motor went from the size of a watermelon, now it's the size of a stack of pancakes. And of course, other technologies in avionics, in aerodynamics, and structures further synthesize together to make, we think, the possibility of electric propulsion in general aviation very real and very near term. Here on the right and the left, you can see, of course, the Sunflyer. The Sunflyer is solar electric. You can see on the wings solar panels. Notice the nose of the aircraft is very sleek. The profile of that electric motor allows a much, much more aerodynamic nose. The batteries, about 300 pounds of batteries, are in the nose of the aircraft. The wings completely dry, no fuel. Solar panels provide about 15%. The regenerative propeller, another 15% of energy collected back into the airplane, together with the batteries in the nose, and we're looking at 2 to 3 hours of flight time, battery only, over 3 hours of flight time as a trainer. And of course, the Sunflyer is the beginning, it's the entry point of a family of aircraft, much as Airbus has discussed. Go from a 2-seater to a 4-seater, and so forth. Well, I started out as a young person in grade school. My parents were both new pilots at the time. We got a Piper Cherokee 140, and that opened up for me the adventure of flight. I was so excited. It was an amazing experience. But one of the things that was critical about being able to do that in those days was that gasoline was inexpensive. The airplanes didn't cost very much. We didn't have the liability risks and burden on the industry. Fuel was cheap. The adventure of flying was opened up for all of us. How exciting, truly, how exciting. My dream was to become a test pilot, to become a fighter pilot. And I was fortunate enough and focused enough in my life that I went on to school, engineering school at the University of Washington. I went on to become an Air Force pilot. From 1983 to 1988, I trained fighter pilots in Texas, Wichita Falls, Texas. I was fortunate to also train the young fighter pilots about aerodynamics. And later, after Desert Storm, when I left the Air Force, I continued in developing the new products coming out for training, the T6 JPATS trainer. I was a program manager for that. Some of you may know me when I left the Raytheon flight safety effort on the T6. We launched the Javelin project. Many of you may know us or know me from the Javelin days. But since we started the electric programs back in 2008, 2009 timeframe, our focus has been to bring the synthesis of these various technologies together to revitalize this aviation, general aviation, that we all love so much. But it's not just recreation. Some of you are well aware, our commercial pilots today, the airline pilots, of course, are almost entirely civilian. The military is not the pipeline for airline pilots like it used to be in my era. Boeing is forecasting some 558,000 new pilots, commercial pilots, needed over the next 20 years. That's a gigantic demand. And some of us may know we only have about 140-some thousand pilots today, so it's 3 or 4 times more than are in existence today. The demand for pilots is growing at an immense rate, and our current commercial pilots are nearing retirement. The demographics, of course, are moving us in our era towards retirement, while there's gigantic demand. Of course, at the same time, the era of general aviation in the 60s and 70s, the aircraft, the legacy aircraft that we all fly today are, decades old. 30, 35, 40 years old. So the point of entry, the training fleet that we have today, is nearing the end of its effective life. While the demand for pilots is growing so greatly. And of course, to help answer that, we want to bring and be a part of the process of bringing a solution that's cost-effective, that's a great training aircraft, that can be the conduit through which the exciting and new experience of flying can be done. Imagine being able to fly with $1 of electricity per flight hour. $1. $1. The possibility of flight training going from the profession and the experience today where you can spend $100,000, $150,000, even $200,000 going from ab initio to your ATP rating. Imagine cutting that down by more than half. Imagine that. So what are we doing? How is our company accomplishing this? Of course, there's the technology aspect, and there's the airplane aspect, together with the business. And I have to say, I don't know if do we have any FAA representatives here? I don't know if we do today. One of the things I just briefly want to acknowledge is our great friendship and support from the FAA. I know in general aviation it's hard for us to say that, but truly they have been partners with us in this process. We're very, very grateful to them. Charlie Johnson, as some of you know, is our president and COO. Charlie brings with him decades and decades of experience in general aviation. I think in large part our relationship with the FAA is due to that friendship that has developed over so many years with the aviation leadership that we have on board. But one of the real key differences with what we're doing, the Sunflyer is not an ultralight. It's not a light sport aircraft. It's to be certified under Part 21. That allows a fully certified day-night VFR trainer. And the second key to that is it allows a 1,700-pound gross weight limit. We're not constrained by the lower weight limits that a light sport aircraft would have. That is really key to bringing along that 2, 3, and more flight hour requirement. Yes, training typically is an hour, hour and a half sortie. That's for sure. And that makes an ideal entry point for solar electric aircraft. But being able to be certified adds an element of safety and review and process with the FAA, but it also allows the heavier weights to accommodate the appropriate balance of energy for a safe flight and lots of reserves. Twice what you need for a typical training sortie. So our gratitude truly to the FAA. We've negotiated a Part 21 certification basis for the airplane. We should be flying our 2-seat prototype aircraft by about the first of the year. It's under construction today, getting very, very close to rollout. We're excited to be announcing that in the coming weeks. But the basis that we're going forward with the FAA is a Part 21 certification. I mentioned a minute ago, it's not just batteries, and they're very cool. Like I said, the energy density of those batteries is improved by 100% in just the last couple of years. Knowing that, if we get the configuration right, you can imagine, again, going to a fully capable family of aircraft. If the battery technology is improving 10% a year, imagine being able to swap out those batteries as you improve in the coming years and getting a 3, 4, 5 hour, even 6 hours, surpassing a conventional general aviation aircraft fuel, limited by fuel. But it's also solar electric. The solar panels that we had back in that electric Cessna project era 3 years ago, they were 11% efficient in converting sunlight to electricity. We're at 24% efficient solar today. We expect by production we'll be at 28% efficient thin film photovoltaics. In the coming years, surpassing 30%. Imagine again that free energy contributing so important energy to the overall performance and endurance of the aircraft. The structural system of the airplane, we carry about 450 pounds, about the same as a 152, 172 Piper Cherokee kind of a thing. But imagine the aircraft equivalent in structure going from aluminum to a carbon composite, literally cutting the structural weight of the aircraft in half. Aerodynamics, batteries, structure, all come together with the emerging motor and battery and solar technologies. There's a picture of that's a 26 kilowatt motor. Again, literally the size of a stack of pancakes. Those are lithium-ion batteries, 18650 Panasonic batteries. Those particular batteries are 250 watt-hours per kilogram. And I know energy density is relative, but again, moving from where we were in the electric Cessna days to doubling that energy density is a representation of just this rapid acceleration in technology that we'll all benefit from. solar cells on the wings. Obviously, on a cloudy day or flying at night, not going to contribute much, but as much as 10 or 15% of the energy on a sunny day like we have here in Palm Springs often. Most of our flight schools, of course, are across the southern tier of states, Texas, California, Florida. Of course, we have many flight schools in Arizona and Colorado as well. But that energy is free, and it's supplementary to doing the mission that we're doing. And imagine our recreational pilot friends who enjoy flying in remote rural areas or they fly the fence line for their farm or their ranch. Imagine our friends in Africa and Indonesia and across the world that don't have access to aviation gasoline. Maybe the missionary efforts, charity efforts, not having the requirement for even the electric grid. Those solar covered wings enable flight without those limitations. Here's a picture of our friends at Pipistrel. They have spent a great deal of time in working on a regenerative propeller design. The aerodynamics very, very specialized so that it's efficient in providing thrust, but when you're descending, it becomes a windmill. The other direction, the energy you put into the climb, you turn right around and receive back into the batteries as you descend and land. Maybe through a whole series of touch and goes, using energy while you're climbing, collecting it as you descend, slow down, and land. Again, depending on the conditions, 60 knots, 400 feet per minute rate of descent, that's about 1.5 kilowatts of energy with our weight class of aircraft. Very same with our friends at Pipistrel. We really appreciate what they're doing. We often share and support each other through technical discussions, and one of the things we've even looked at is working together on their propeller. So we really appreciate that. Notice also, though, that the nose of the airplane is much like a jet nose. Electric propulsion is about 35% more efficient in turning energy into thrust. And you can see that part of the reason for that is the nose of the airplane doesn't have the large cooling block that we have typically required for an internal combustion engine. So that area becomes area where thrust can be added. The aerodynamics of the propeller are more efficient. So the cooling aspect, the form drag, and the aerodynamics of the propeller all work together to provide a much more efficient propulsion system. Of course, it can't just be that the airplane's electric. It has to be an effective training device, an effective, well-flying airplane, a robust airplane. And again, so important that we've built a team with Charlie Johnson and so many others that have the history and the knowledge of building a highly effective training aircraft. It must have the flight characteristics and behaviors that are both safety and a training environment to bring these new pilots in and obtain their licenses. Easy to operate, safe in so many ways. An integrated training system, of course, working together with friends like Spartan. Spartan Aeronautical College is taking a deposit agreement with us for the first 20 aircraft. We really appreciate Spartan's leadership. Working together with Redbird Flight Simulations to create a simulator training companion to the aircraft. We really appreciate Redbird and their leadership in technology. All of this working together to create a training system with an entirely new paradigm, an entirely new cost paradigm. The airplane is about 36 feet in span, weighs about 1,500 pounds. Our takeoff speed's around 55 knots, Generally speaking, the operating is around 80 knots, you know, plus 10, plus 20, minus 10, minus 20. Top speed is 120 knots. Right now, we're looking at a climb rate of about 1,000 feet per minute. This aircraft outperforms the 172 that we're replacing in every regard. Coming along, the final leg, of course, will be the endurance. Right now, about 3 hours, but we're looking at 4 and more as these batteries improve in the coming 2, 3, 4 years. I love this chart. We should all love this chart. Notice the yellow across there. Cessna on the one side, Sunflyer on the other side. That is the bottom line, isn't it? I like that $1. 1 is a good number. You can sum up all kinds of things. You can talk about, you know, 1 moving part on electric, you know, 946 moving parts on a Lycoming. You all gotta love that. Maintenance, annual inspections. But really, when it gets right down to it, it's right here in your wallet. And you look at that bottom line. You gotta love that line. So we've been flying the E1. You can see there Charlie Johnson in the seat. That's John Knutson, the former co-founder and president of Atom Aircraft. Kerry Beresford, our chief engineer. In the E1, our German friends created the baseline aircraft that we've modified as our technology demonstrator. We've been flying that for the last year and a half. Again, some of you may have seen us at Oshkosh with Redbird. We've been getting a lot of great data collected on that R&D project. And of course, there's Charlie and I sitting in the 2-seat aircraft that we'll be rolling out literally, as I said, within a few weeks. We expect the Sunflyer prototype to fly over 2 hours, maybe again kind of approaching that 3-hour time frame, but far, far in excess of the 45 minutes, hour and a half that some of the other electric aircraft projects have been flying. We can't do this unless we do it together as a team. All of us here, leadership of general aviation, all must work together. That's the only way this is going to be accomplished. In our view, we're very honored to have the leadership team that we have. You can see Craig Fuller and Gretchen from the former president of Mooney. Of course, Charlie I mentioned before. Jerry and Larry, many of these people I'm sure are all well known to you. And if they're not directly on our board of directors, they're supporting us as strategic advisors. You can see Jack Pelton and Pete, many other names that are all well known to all of us. Because together, we can change general aviation. We can bring excitement back into our flying experience, which is so important, not just for us as pilots and recreational flyers, but for commercial aviation and for transportation that our nation and world depends on. So we really believe, and I think together with you, that the dawn of aviation is upon us. And electric propulsion is enabling that possibility. Thank you very much. I think we were allowed a little bit of time for a couple of questions. If I'm not mistaken, I think we're doing pretty well here. Do we have, I know there are a couple of questions. Here we go. I want to make sure we're responsive here. I know this is a fascinating topic, so I want to make sure we have a little Q&A here for just a few minutes.
This is kind of like, how long is your extension cord?
I love it. It's okay.
What is the nature of the connection that you have to have on the ground? How long does it take to regenerate? And can the solar panels be regenerating batteries while it's just sitting during the daytime?
Absolutely. Solar panels are working full time all the time. So the airplane is sitting there. If you're a weekend, you love flying on the weekends, the airplane is recharged for you without even plugging it in. Then, of course, for those of us that have electric cars, we know we have kind of different sizes of chargers. You know, there's kind of the basic charger you plug into the wall. You have superchargers that are like, you know, plugged into the dryer type of thing. So the recharging time it depends. You know, it can be 1 for 1 hour for 1 hour flight. It can be 2 for 1, depends on the charging system. For a high ops tempo flying school kind of environment, we're looking really at a battery swap. So the batteries come off, the airplane is designed for a quick exchange, under 5 minutes. The battery truck comes up instead of the fuel truck, swaps the batteries for a fresh set. While the airplane's off on the training sortie, those batteries are on a supercharger going through a very nice, even recharging cycle. That enables the longest possible life for those batteries, you know, 1,500 cycles kind of a thing. So very, very important, we feel. A great question, but the answer is it kind of depends. If you're a recreational flyer, what your charging system is. If you're a flight school, maybe higher ops tempo, probably you're working with a battery truck to do that quick swap. Sorry, yes, sir.
So for batteries, you always have the trade-off of how heavy they are versus how much protection they have. Like the 18650s are nice off the shelf.
Yes.
And you have lipos that weigh less and give you more, but catch fire if you puncture them. How did you pick those versus some that are more efficient, but maybe need a bit more protection around them?
So the Panasonic 18650B has a tremendous amount of research behind it. Each cell has an individual battery management chip on it. Then the battery pack itself has an additional battery management system. Then there's a collective battery system monitoring capability we have. There are more advanced batteries on the research tables today. But of course, the key thing for all of us, the number one thing with the FAA and for us as aviators and those of us that design airplanes is safety. So while there's exciting battery technology on the horizon, we want to make sure it's gone through the entire gauntlet of research. We want that battery to be absolutely as safe as possible. So Panasonic 18650B, again, many of you may know Tesla uses that battery system. You know, billions of dollars have been put into research behind that battery safety. So we're borrowing technology from the electric car industry where they put so much effort on making sure those systems, battery systems, are safe. Great question. Sorry.
Right here.
Okay.
Can you tell us what charge per kilowatt hour of electricity you've based the $1 per hour?
Yeah, 10 cents. We use about 10 kilowatts per hour flight average. Now that includes, you know, another kilowatt and a half or two that we're taking credit for back on solar. It includes another 1.5 or 2 kilowatts that we're getting back from the regenerative propeller. So in total, we're consuming maybe 12 to 14 kilowatts average per flight hour. And we've got 10 cents a kilowatt hour out of the wall on average. It's not consistent. Of course, some airports are more expensive, some places in the country less. But that's how you get to the dollar. Okay.
What's the projected cost for the plane and replacement batteries?
It's the introductory price right now. We are taking deposits, as I mentioned, Spartan Aeronautical College, Independence Aviation, Aviation Adventures. There's a flight school in Paris, France, Aero Touring Club de France. It goes back to 1903. Right there in Airbus's back door, we have a Sunflower deposit from those historical, I mean, what a cool legacy there in Paris, France. But they're excited about the future of aviation. They're embracing the future. And so I thought it was so interesting to partner with them for a Sunflyer aircraft. But anyway, 35 deposits now, and introductory price of $200,000. Will probably be in the 220, 240 range as we go into production after we get certified, about 2 years out.
What about maintenance considerations at FBOs? How do you bring the existing maintenance cadre up to speed?
Great question. So part of what we'll be announcing soon, of course, is a network of support. Maintenance on an electric airplane is very, very minimal, literally one moving part. But it's a primary propulsion system, so there'll be a little bit more focus on electric motors, of course, with the A&P cadre coming up to support the Sunflyer. But announcing a network of FBOs will be coming up in the near future, and I think that's what's critical for all of us to kind of understand, that this isn't just going to be a flight school-centric aircraft, but a possibility for us, all of us who enjoy recreational flying, and having chargers at FBOs to support our aircraft as we go cross-country.
Yes, Mr. Bai. My name is Rick Tutt, and I live in Stockton, California. I'm a career flight instructor, and I really endorse this. And I think many of us here probably remember Heathkit and solar panels charging 9-volt batteries. But cart before the horse, where are all the kids? Who are you going to teach how to fly? I don't see any anymore. And I don't see any kids at the flight school. And maybe there are in other countries, but we're here in America. And I think my main question is there's a component that's missing, and that's the education component. How are you going to reach out and get the kids? Where are the kids from the greater Palm Springs area that could have been brought to this event?
Well, thank you so much. And it's people like you and all of us that carry the burden of the excitement of aviation to the next generation. That's so important. Yesterday I was at the Museum of Flight there in the Denver Centennial area. And we had a group of school kids there as we were unveiling, cutting the ribbon and this new Museum of Flight cooperation with the local education community. They have a goal of training, flying a teacher every week, who in turn, with the excitement of flying, will share that to their classes. So, yes, we agree. One of our jobs is to create the conduit through which the excitement can be transmitted with a cool, electric, high-tech, new training airplane. That helps a lot. But we still, as the audience here, need to transmit that excitement to the new generation, to the young people. And that's a community effort. That's something we have to all do together. And we appreciate your comment.
Certainly bringing new people in to general aviation, new flight students, is key. Currently, we're graduating about 16,000 to 18,000 new pilots a year.
Yes.
AOPA's research showed us that the dropout rate is somewhere around 80%.
That's horrible.
What are you looking to do to solve that issue? We're losing 75,000 aviation enthusiasts a year as it is.
Yes, and of course there's a whole host of reasons for those dropouts. And some of you maybe have even seen the surveys. One of the things, again, I think that's so important is to get the cost of flying down. It's such a challenge to keep writing those checks. And of course, we're flying the great aircraft, legacy aircraft, but 30 and 40-year-old aircraft, that's hard to get people excited. So if we can address the aircraft styling, the aircraft training effectiveness, the technology and the avionics and so forth, together with getting that cost down, I think that's so critical to keeping people in training programs where they feel like they can afford and enjoy the training experience. That's really, in my view, that's really what we need to do. That's what we're trying to do. I think we got time, maybe one more.
The last one's here.
Okay, yes, sir.
Hi, you're obviously well on your way to, or you're basically replacing the 150 and the 172 with this amazing technology. Do you have any estimates on when you think the 6-seater class could possibly be replaced by this kind of technology? The Piper Saratoga is the Cessna 206?
Great question. This is the precursor of a family of aircraft. If we do this well, there is no doubt the 4 and 6-seaters are coming. Battery energy density is improving 10% a year. That will enable that 4-seater and the 6-seater. The Part 23 rewrite that the FAA is working on, we expect, well, it's the FAA, but 2 to 3 years or so, something like that. And the propulsion category under which we'll fall is 6,000 pounds or less. That's perfect. So yes, indeed, we do expect the 2 and 4 and 6-seater. We do expect to see the light twin. The technology today will enable that tomorrow. Thank you very much.
Thank you, George. What a way to start the day. The exhibit hall will be opening in just a couple minutes, so I invite you all to head over there now. And tonight is our party at the Palm Springs Air Museum with live entertainment and food and drink, and it's going to be a great time. It's a costume party, so if you have a costume to wear. 1940s Aviator is the theme. So everybody have a great show. See the airplanes outside. Enjoy the exhibit hall, and thank you very much for coming.